Okay, everybody, I am going to go ahead and start. This is week one. There's no participants, so it's not that big a deal, but I'm going to go ahead and start so that I can record this and provide this for those who may need the extra information for what's going to go on in week two. So basically, I am going to cover initial questions, which there are not any. So it's going to be a very quick session. We're going to discover from week one feedback, some things that I saw that I just want to spend a couple minutes clarifying and elaborating upon. Then I'm going to cover types of supply chains briefly, a concept that's very important as we go forward called risk pooling, in which we aggregate variance of multiple locations in order to reduce the variation within a system. Then I'm going to talk about principles of postponement, which is a way to reduce variation within a supply system, which is a supply chain strategy that we can use. And then I'm briefly also going to cover the Deming system diagram, probably towards the first part of the week one feedback. So without further ado, I'm going to go ahead and start. Week one feedback. I'm going through everyone's assignments so far. I've noticed just a couple things that I'd like to just expand upon. There was some very good feedback on a lot of the assignments, especially considering how this is week one. In week one, there's usually a lot of really good ideas going out there, and I'm going to hopefully hone some of these ideas to provide a little more information so that everyone can learn from it. But as always, please feel free to send me some questions or some feedback. You know, if your experience tells you something different than what I've stated, please let me know. I will be more than happy to discuss it and see where we can go from there. I'm always for people stretching the envelope. So first topic here, data gathering frequency and forecast variation. There was a couple people who had mentioned that the more you gather the data, the quicker, the better the lower the variation in your forecast. Although that can be true, just remember that if you have any short-term spikes that are from what I would call special variation, the variation that comes from special causes that are not common to the system. Like for instance, let's say the demand for aluminum foil spiked because of asteroid particles, which is a 1 in a million chance. I know I'm really making something that's weird, but obviously if you take that demand forecast at that point and you see a high spike in demand, you go, oh my goodness, my demand is higher, and you may react accordingly. You still need to take your data gathering within the context of previous data. I'm going to post something on variation where sometimes you'll use what's called a running metric, where you may take like the last 3 months, and as you go forward, you may drop the last, drop the last data. So you always have the most recent 3 months of data, and you may go forward. You may choose 2 months, 1 month, whatever. There's always a risk that if that gap is too narrow, you may not have enough of a sample set to give you your true demand and your true demand variation. As I mentioned before, variation, well, as I'm going to mention in a post that you're probably going to get Tuesday, variation is something that should be understood and reduced. You can't always eliminate all variation, and it's very hard to try to eliminate it, because seasonality, certain things may come up that may increase your variation unexpectedly. The best thing to do is to understand the variation and try to reduce it. Now, you can induce artificial variation through inaccurate forecasting data. You may have people sampling it in different parts of the demand chain. Like, let's say a retailer may give you different data than a distributor. And sometimes there could just be errors in the data collecting by either of those. So sometimes the way you aggregate the information is also very important. So just keep that in mind. So product support and the canary in the coal mine. I made a mention this to a couple people in the class, that usually product support or the customer service folks are the first to detect supply chain changes due to customer reactions to products. And everyone's probably seen it. You buy a product, and sometimes the product doesn't meet your satisfaction. So customer support will detect that customer demand may decrease because of this lack of satisfaction, or maybe there's a design flaw, or something that causes the customer reaction such that future demand may change. Or sometimes product support will realize that some customers, and I've actually seen this, some customers say, hey, look, just so you know, I'm going to be needing a whole bunch of these widgets within the next 3 or 4 months because of bad weather, asteroid impact, or whatever. So what can happen is customer service goes, oh my goodness, I need to tell you. But in many cases, in most organizations that I've studied and that I've worked for, product support and customer service are disconnected from the supply chain. Marketing is usually also disconnected from the supply chain. This week we had a lot of marketing questions that really came out, and if you think of these marketing questions as a supply chain guy or girl, pardon me, you may think differently than a marketing person do, and therefore the organization as a whole's reaction to that marketing data or that supply chain data will differ based upon what's more important, either making a whole bunch of stuff or selling a whole bunch of stuff. So just keep that in mind as we go forward. So demand spikes and long-term profitability. There's a couple people that mentioned that when you have artificial scarcity, such as like you suddenly decrease the number of items available in a market, you have a demand spike in the short term, because people end up going, oh my goodness, there's a scarcity of these products, the price goes up and profitability goes up in the short term. But in the long term, what happens is the customer is going to hedge his bet, his or her bet. So for instance, let's say a very good idea, Black Friday or holiday shopping. We had this discussion in the last course that I taught, where Nintendo likes to artificially create scarcity such that they'll only make so many, so that they can charge a lot of money for their consoles. This is something that Nintendo has done for a very long time. They're famous for this, and Sony was also. When they were the big people on the block, they would do this a lot because they'd be able to pretty much write their ticket. And Apple does this to a certain extent with the iPhone. I had a person in my last class, who worked for Apple, and he was telling us that Apple actually designs this into their demand forecasting and how many consoles or how many phones they're going to make. So in the short term, this works out fine. You know, people want your product and they buy your product, but in the long term, they're going to decide, well, maybe I might want to look for a substitute. So ease of substitutability is a very important concept within this. So they go, well, I might not be able to get this Nintendo console, but who else provides a product? And maybe Sony provides something that's very close to it. So they may say, well, I'm not going to put up with this artificial scarcity or the inability to get a product. Instead, I'm going to go to a consumer. And Apple has felt this to some point when Samsung came in and started to take some of the business from the iPhone. Product utility is very important. Once again, if someone can get the same amount of utility from a substitute as they can from your product, they'll be more apt to go to their product. So although everyone who is saying that profitability will increase when you have scarcity and you will have a demand increase, you are fundamentally true, but just realize that there are some caveats to this. There will be a lot of caveats that I bring up in this class. Just realize that these caveats are something that we just need to expand upon. So increased product lines and system complexity. What was kind of missed in the MedTech example was the fact that they had all these product lines. When you increase product lines in a system, you increase the complexity of the system exponentially. Okay, and this is an important concept in any system. Anytime you increase the variety in a system, you increase its complexity. Now, there are things I will talk about in a minute, principles of postponement, where you could do something to address this complexity. But just realize that if you increase product lines, you will generally have an increase in system complexity, which in general creates a much more difficult time for supply chain to address these issues as they go forward. So just some things to keep in mind. As I said, these are all very good answers, but I just want to provide this just to give you something to think about as we move forward. Now, this is Dimming Systems diagram. I just want to go over this very briefly. I use this in all my courses, and you'll rarely see this, but this shows the supply chain as a closed loop. Basically, in the bottom, this is an organizational diagram, but you can replace receiving, production, inspection, and distribution with manufacturers, distributors, and retailers, and then the customers, and then the product is used, product support, and product design or redesign. So if you notice, once a customer gets the product, they use the product, the first person who gets feedback about the product is product support. If you have a customer service line. If there's no customer service, then you lose the ability to understand how the customer finds utility or uses your product. And as a result, your ability to learn from your product and to learn from the customer's use of your product is very limited. Some companies I've seen reduce product support to mainly a bookkeeping function where you call in, they log your problem, and then they may send you a new product, or they may have something on a website. Although that is useful to a point, it really misses the value in having a product support function. Product support, when it's linked with marketing and with product design, is a very useful tool in creating a spiral design where you can holistically evolve a product. And while also understanding how your product is performing within the environment that it is intended for. So just keep that in mind. As always, please feel free to provide feedback in the class if I can ever clarify any of this for you. So there's two types of supply chains that we deal with. You'll probably remember these from different names, but I'm going to go over both of these really quick. So the first type of supply chain we have is a build-to-stock supply chain. It's very simple. Build-to-stock supply chains operate by creating products ahead of a forecasted demand. These demands are based upon sales forecasts and or historical demand data. It really hinges on forecasting of future demand. That's very important to remember. So this is a type of push strategy within a supply chain in which we create products, we try to anticipate how much product is going to be needed, and we push products through the supply chain to get to the end user with the intent of selling these products. And hopefully your forecast is going to match the amount of products that you create. This is very complex, but there's a lot of different factors inside that may influence your ability to meet that demand. Yeah, so this is related to mass production philosophy. This is what originally came out. Excuse me, quick yawn. It's 9:30 here, so apologies for the yawn. So it's related to mass production philosophy, where in the old days, you basically would create as much product as possible and then sell it on the market. Well, over time, like with cars, at first it was great. You know, Henry Ford was able to sell as many cars as he could, as fast as he can get them offline. But as competition began to appear, they had to change the mass production philosophy to begin to forecast demand. So there's also allows for economies of scale, because now you can forecast, okay, what's my break-even point based upon fixed and variable costs? If you study theories of constraints and lean also, they TCMO talks about economies of scale being a fallacy. Although it is true in a sense, economies of scale is the ability to spread the fixed costs over more and more items, therefore reducing the cost per item as an accounting move is an effective strategy. If you guys are interested in understanding how that works, we could try to, oh, sorry about that. We will discuss that as we go forward. So, build a stock is effective when we have these 4 general factors. Either we have low demand variability, or few product lines, low production variability, or shipping buffers. Well, actually, just those 3. I'm sorry. Low demand variability, few product lines, and low production variability. I'm going to pause this for a second and see if I have a problem with my recording. Okay. I had a little bit of a glitch. I want to make sure that I didn't lose my ability to link up with the rest of the class. So I guess I'm back on. So once again, build a stock is effective when we have low demand variability. Once again, because we have to build based upon sales forecast, we want to have as accurate a demand forecast as possible. Anytime you have any variability, that requires flexibility within the supply chain to absorb, which mass production typically does not have that kind of flexibility. You can design it. There are push-pull systems that are a hybrid that do very well towards this, and we'll be discussing this in week 9 or week 10, so keep that in mind. So you have few product lines. Once again, we want to reduce the complexity of the system, so we only want a few product lines to produce to, and we have low production variability. We want to make sure that we are able to produce at a reliable rate. This also has to involve capacity. You must also have the capacity for the demand at the other end. And your capacity obviously must be higher than the production to include the variability. So shipping buffers can be used to mitigate the variability and demand. We're going to talk about safety stocks and shipping buffers. Shipping buffers are a theory of constraints term for a type of safety stock. So we'll discuss this in more detail as the classroom goes forward. So build to order. Build to order is also called make to order or made to order. And this is very similar to a pull type strategy where products are not manufactured until a confirmed order is received. This focuses on current demand information to be successful. About the best that I've seen that does this is something like Amazon, where Amazon requests, well, once something is sold online, they pull a product. Obviously, there's some give and take in this system. We're going to cover that in more detail as we go forward, but just realize that a pull system, usually there's a bit of risk involved based upon who is responsible for the cost of the inventory. Once again, similar to a push strategy, there's always going to be some variation, and you won't be able to have something instantly appear. Like, for instance, if someone buys something right now off of Amazon, the order isn't immediately placed, obviously, because you have time constraints, unless you're in Star Trek. But without a transport of some sort, you're not going to have a true instant pull system. So you're going to have to do things like we said before, have some kind of safety stocks or things like that in order to mitigate some of this. So it relies on current demand information to be successful. So in general, companies that use pull strategies, such as Toyota, Walmart uses one in a sense, Amazon, you need to have as accurate of demand as possible. And in theory, this needs to be shared throughout the supply chain. You need to make sure that the suppliers know that they need to make something now. Toyota does staging, so they understand the expected demand, and they say, hey, suppliers, we have intermediary stocks that need to be filled with so much, and we instantly pull stock from these intermediary stocks. We're going to cover this in more detail as we go forward. So a pull system is really dependent on everybody having current demand information, and you must also have a short lead time a short time between the manufacturer and the retailer. So useful for supply chains with low volume. Obviously, with low volume, you're better able to with low volume, you don't have to worry about well, I'm trying to see how I can say this easily. Low volume is much easier, like to match the demand. If you have low volume and a short lead time, it's easier to meet demand than if you have high volume and short lead time, because the larger the volume, the larger the possibility for large variances. So flexible supply chains, lean supply chains really do well in low volume. Not to say the high volume supply chains can't use pull, but low volume ones are usually a lot better. Toyota's obviously they use a pretty good pull system, and they're a high volume. So it's not necessary to say that only low volume people can use pull strategies. I don't want to make that assumption. It's just a low volume. Usually supply chains with low volumes lean towards pull. Okay. So high product customization. If you are a low volume person with high product customization, then pull is good for you, because it allows you to add customization to less items. Pull strategies are a lot more flexible in that they could deal with product customization better. Also, short lead times is important. Obviously, with high product customization, short lead times, they sometimes don't go together. High product customization is basically almost like the same as an additional supply line. I'm going to cover principles of postponement in a minute. That's going to go into that in more detail. And high delivery reliability. You want to be able to, your customer service level, the ability to get the product to the customer must be very high for this to happen. Because you have low volume and short lead times, you don't have the bandwidth or the speed to pump out extra products if something happens. True, some lean supply chains can build it into it, but in general, you need to have high delivery reliability. Okay, so next slide. Now, risk pooling. Risk pooling is a method to reduce variation across several locations by aggregating the demand variation across multiple locations. This is a concept that the book covers, that the class covers in like week 4, but I want to cover it now because this is important for week 2's answer, and is also a very important concept going forward. This is a very powerful tool for reducing variation amongst a supply chain. Now, this is based on the law of aggregation of demand, in which certain things must be true for this to work. So the law of aggregation of demand basically states that higher than average demand at one location can likely be offset by lower than average demand at another location at the same time. So basically what this says is that if you take a large number of locations, the odds of everything being high or everything being low at the same time it's very low. More than likely, all things being equal, one will be high, another one will be low. So your variation will be smoother across multiple locations. So the 2 rules that must be true for this to work is that the demand at individual locations must be independent of each other. For instance, customers can't be able to go to multiple sites to fill their product. And it applies to demand for a similar product being fulfilled from multiple locations. So all the locations that you aggregate must have a similar product. So if you have a bunch of sites doing apples and a bunch of sites doing oranges, you can't aggregate all the demand because the product is different. And that's important. So the demand at the individual locations must be independent of each other, and the demand for similar products must be fulfilled from multiple locations. Must be a similar product. Very important. So I'm going to go through this example. So let's say that we have a system where we have one distributor with 4 warehouses and 4 retailers. If we also are going to assume that the average demand per site is 30, and the standard deviation is 10. So, and our management has said that we need to fulfill demand up to 3 sigma of demand variation. So it's 3 sigma from the mean. So not 3 sigma total. So it would be 6 sigma total. But since we're dealing with total variation, we're only dealing to the right side of the distribution. So 3 sigma from the mean on the right side is basically we're going to, our customer service level, so to speak, is going to be 99.87%. Obviously, the higher you go with customer service level, the more inventory you need to address it. That's why variation reduction is very important. So 30 plus 3 sigma worth of standard deviation is 60 units per site. So a total of 240 units. It's very simple math. So now let's say we're able to aggregate all of these sites to one warehouse. So, and this is important for the assignment for this week. If we aggregate all of the demand to one warehouse, what this does is we're able to aggregate the variance across all 4 sites. All 4 sites are no longer independently viewed when we deal with demand aggregation. So we still have 30, the average demand per site, and the standard deviation is 10. So each site still needs a 60 units if we're going to fill the required, the management required amount of units. But what happens now is that when we aggregate the demand, we no longer have to worry about the standard deviation of 10 per site. What we're going to do is we're going to aggregate the demand across from all 4 retailers at the warehouse. And then basically the way you do it, it shows you there on the second screen. Let me see if I can, basically right here, it shows you how you calculate it. It's very simple. You take the demand variance at each location. The demand variance at each location is 10. And you square it. Once you square it, you add all the demand variation up. So now we go 4 times 1,000, which is 400. At this point, then we take the square root of 400, and that gives us 20. Okay? So now, the aggregated variance, so the inventory that is needed at the warehouse is still the 30 times 4, because we got 4 retailers and 30 each, which is from right here. Okay, but now we're going to aggregate the variance. So the variance goes from 10 across all these sites to 20 aggregated here. So warehouse A has to basically absorb 20 units worth of variation across all 4 retailers. And we multiply that by 3 sigma, which is our management mandated level of demand variation that we have to do, which when we take all this, it gives us 200 units. So by aggregating all the demand across 4 sites, we're able to reduce inventory by 40 units. Okay, so as a result, we have decreased inventory. Now, when you do this, realize you have other factors involved. You have like transportation costs that you have to worry about, storage costs at warehouse A. You know, there's a big list of these in the book for this week's assignment. So just think about all these factors and try to determine, you know, best guess what would be a good strategy. I'm not looking for a big mathematical thesis on this. Just tell me how you would go through this. I'm going to post a video that I created for my last class on how to calculate, how to work on this problem a little bit better in one of the announcements. So feel free to use that, and if you have any questions, please feel free to let me know. So I just wanted to cover risk pooling early so you had a chance to understand it before we went forward. As always, please feel free to send me any questions that you may have during the week, and I'll be more than happy to fill them out. Now, principles of postponement. This is something that I don't believe is covered in the textbook, but this is something that's important when you're talking about absorbing variation within a supply chain. When we go to systems theory, Ashby's first law of systems is that only only variety can absorb variety. So when we have increased variation, external variation, we have to increase the amount of variety within the system. And basically, let's say we're selling cars. Ford, only sold, his famous saying is, you can have any car you want as long as it's black. Let's say he suddenly wants to sell red and yellow cars. Well, all of a sudden, he may have a huge demand for red cars that he didn't know about. So to absorb that extra variation, you have to be able to basically increase the ability to make more red cars. The other way to do that within an organizational context is to limit the external variations effect on the system by saying, hey, I don't care if you want red cars, we're just gonna scrap red cars and we're just gonna go back to only making black cars. Obviously, when you do this in a competitive system, you end up losing sales to someone else who says, hey, I can make you a red car. Okay, but these are two strategies that you can do. So you either increase the ability of the system to absorb the external variation through flexibility, or you basically minimize the amount of variation that we're going to address by basically saying, we're only going to make black cars. We're done. So in principles of postponement, what you do is you modularize and you use common components as far up the supply chain as possible before you create multiple different designs. Boeing used to do this quite a bit, in which they would offer you 7 or 8 types of seats, different colors and everything else. But eventually, when I went to Boeing, they found out that it was very expensive to maintain all these things. So what they said is, okay, we're going to offer you a plane when it's pretty much finished. And then when it's finished, we're going to provide modular options to customize the plane. This allowed them to push the variation as far up the supply chain so that there's less effect on the system as a whole. Obviously, this requires a lot of design and a lot of supply chain work and a lot of manufacturing work to make sure that you can do this. You can't just do it all of a sudden. You have to design the modularity in your products, say in finished or semi-finished form. So what this does, this delays committing raw resources, labor, and fixed assets as far into the cycle as possible. So this is a quick description here. We have raw materials, and here we have 3 product lines: fabrication, assembly, finished goods. And what we're going to do is we're going to only have one product go into fabrication, and then once it's in fabrication, then we're going to modularize it so that we get the 3 product lines from assembly and finished goods. What this does is this reduces the variation. Oops, hold on a minute. This reduces the variation here. Whoopsie daisy. Hold on a minute. Let me just. I don't want to. Oh, here we go. This reduces the variation from 3 lines of variation to one line. Kind of like your risk pooling. You're basically pooling all the variation on one line instead of 3, which allows you to better manage the variation from one line. Okay. This is a very powerful tool for improving the manufacturing of a product as it relates to a supply chain's demand. But once again, this takes interface with many different actors within a company to be able to get this done. Okay, and then, as I mentioned earlier, real quick, simplified supply chain system. So we have the suppliers, which provides the raw materials. This aligns with one of the diagrams in the chapter where we have work in process. So work in process is your receiving, production, and inspection, and then distribution is your finished goods, and it goes out to the customer. Lead time, I want to bring it up because in some cases, lead time is measured differently. In some cases, a supplier views lead time as basically, basically getting the raw materials to the point that they're finished with the product. Distribution sometimes views lead time as a product going from the supplier to be received from the distributor. And retailers usually view lead time as a time that the item is ordered. So we have the time that it's ordered until the time that the order is fulfilled. Okay. So lead time, when you deal with lead time of a product, I usually recommend that people view the entire chain as a lead time. What this does is this allows you to understand the effect of every section of this system. So if your time to go through a supplier 7, and each of these is like 5, 5, 5, we'll just say make it for 15, so that's 22, and distribution is another 5, so 27. If it takes 27 days to go from the time that the product starts to be made to the time that it is received by the customer, then you can start to attack various parts of this to understand where we could decrease lead time. Unfortunately, a lot of these people do not like to talk with each other. So once again, you could replace receiving, production, and inspection with the manufacturer and a distributor and maybe a warehouse and then a distribution. I use this as a model for organizations when I teach operations and how products go through an organization. But the same can be viewed from a systemic point for supply chains when you deal with multiple companies. Same theories apply. So in many cases, this stuff is masked. So maybe the distributor only knows the point that it is ordered to the point that it's fulfilled, which, okay, that may be all that they may be worried about. But what if you suddenly have a sudden change in your demand and you need to say, hey, supplier, we need our parts quickly? Well, if you try to move to a just-in-time system and the supplier is 7, that's the time it takes for him to go from raw goods to manufacturing. Well, you may say, hey, look, I need products quicker. If you go such that they use up all their stock or all their strategies to get the product to you within 27 days, and they suddenly need to go faster than 7 days to get products created because they're running behind schedule or they didn't do a good demand forecast, all of a sudden you're going to see these ripples. And they usually start small and they get bigger and bigger until all of a sudden 20 days later, there's no product. Where's my product? Well, if you only worry about your part of the supply chain as it deals with lead time, you're setting yourself for failure. So later on, we're going to learn about relationships within a supply chain being very critical to the success of a supply chain. Once again, keep this in mind as we go forward. This is just provided to you to give you some ideas as some food for thought as we move forward. Once again, it's very difficult to get everyone to agree to this within a supply chain because as I mentioned earlier, organizational and multiple organizations find it very hard to agree and share information and work as a team. We're going to talk a little bit about Walmart later on in this class, and they're famous for beating up their suppliers. So suppliers suddenly are reluctant to work with Walmart, even though it's usually in their best interest to work with Walmart. So once again, keep this in mind. Okay, with that, there's obviously no questions because I'm here by myself. But if you do have any questions after watching this video, please feel free to post them in the general discussion section of our class, or if you want to email me directly, please feel free. You're always welcome to do that. So without further ado, I want to thank you for your time in watching this. It's going to be about 40 minutes long after I clean it up. So once again, feel free to get a hold of me if you have any questions. I look forward to your comments. Take care.